Good morning. Today we will find out the maximum flow through the given network using the Ford fulkerson rule. So they have given one network here. So we have to find out the maximum flow through this network. So for that we have to identify the source and the sink. The initial point, the point to which there is no inward flow, that point we can call it as a source, and the point to which all the arrow marks they are flowing towards, that is known as a sink. So these all the arrow marks they are towards the 7, so 7 point we can call it as a sink. Now initially what we will do, we will assign this total flow of this network will be 0. So before going for that, we will indication we will come to know. If we write A by B, that shows that A indicate for the flow and B indicate for the capacity. Now initially we are assigning this network flow as 0. In the sense, this becomes 0 by 7, 0 by 5, 10, 0 by 10, 0 by 4, 0 by 2, like that. Everything to be assigned as 0 by the capacity values. So the initial network will be like this. Now you have to find out the Boultonic capacity. Boultonic capacity is nothing but a capacity minus the flow. So here it becomes 10 minus 0, 5 minus 0, 7 minus 0. Initially you have to identify any one of the paths to travel from 1 to 7. Here we have taken the first path as 1 to 2, 2 to 5, 5 to 7. So 1 to 2, 2 to 5, 5 to 7 we have indicated by the dotted lines here. In that path only you have to calculate the Boultonic capacity. Among that Boultonic capacity, whichever the value is least, that least value will becomes the flow value. Here it is 10 minus 0, 5 minus 0, 7 minus 0. That is the Boultonic capacity values. Among that 10, 5, 7 is the least value will be 5. So the flow value becomes 5. That flow value is indicated in the next network. So redraw the network once again, and now you have to add this flow value to the assigned initially assigned flow values. Initially assigned flow values is 0 in the first path. Whatever the path you have selected, in that path only you have to add this flow value. So it is 0 plus 5, 0 plus 5, 0 plus 5. So it is 5 by 7, 5 by 5, 5 by 10. So here it becomes 5 by 7, 5 by 5, 5 by 10. So 5 by 5 it is stable. You cannot travel from 2 to 5. So it is blocked now. So the remaining paths, you can travel any path except 2 to 5. Now select another path. So second path we have selected 1 to 3, 3 to 6, 6 to 7. This is the second path we have selected. Now again calculate the Boultonic capacity. So 1 to 3, here the flow is 0 and the capacity is 10. So the Boultonic capacity becomes 10 minus 0, here 7 minus 0, 4 minus 0. So among these Boultonic capacity value, the least one is nothing but 4. So that 4 becomes the flow value for the next network. So the next network, initially the flow was 5, now it is 4. That 4 is added for the path. Whatever the path you have selected as a dotted line, in that path only you have to add the flow value. That flow value is 4. 4 is added in that path. So after adding 4 in this path, redraw the cycle once again. So when you redraw the picture, so initially it was 0 by 10, now it becomes 4 by 10, 4 by 7, 4 by 4. Okay, now whatever the 4 by 4 is there, round it is blocked again, because the flow is exactly equals to capacity. Nothing can travel from 6 to 7 now you have to select the another path is nothing but the third path is 1 to 2, 2 to 4, 4 to 5, 5 to 7. That is then the path what we are selecting, 1 to 2, 2 to 4, 4 to 5, 5 to 7 we are selecting. In this path, again you calculate the Boultonic capacity. Here 5 by 7 is there. So Boultonic value becomes 7 minus 5, that is equals to 2. So here it is 3 minus 0. Here it is 3 minus 0. Here it is 10 minus 5, that is equals to 5. So among these, the minimum value is nothing but among 2, 3, 3, 5. The minimum value is nothing but 2. So 2 becomes the flow value for the next network. Okay. So we are adding that flow here. First, for the first iteration the flow was 5, second flow was 4, now the flow is 2. That 2 is added to that path. Whatever the path you have selected, in this path only you have to add 2 flow. Initially whatever the flow is there, for this 2 is added. Okay, after adding 2 for this, it becomes 5 plus 2, 2 by 3, 2 by 3, and here 5 plus 2 by 7. Okay, that is redrawn again now. After adding, you will get the table like this. The network will becomes like this now. So it is 7 by 7, 5 by 5, 7 by 10, and here it becomes 2 by 3, 2 by 3, and the remaining values as it is. Now you select another path. The fourth path is selected in such a way that 1 to 3, 3 to 4, 4 to 5, 5 to 7. 1 to 3, 3 to 4, 4 to 5, 5 to 7. Again the same process. Calculate the Botanic capacity. Here 10 minus 7, it becomes 3. Okay, and here 3 minus 2, it becomes 1. And here 0, 2 minus 0, that is equals to 2. 10 minus 4, it becomes 6. So 6, 2, 1, 3. Among these, the least value is 1. Okay, so 6, 2, 1, 3. 6, 2, 1, 3. Among this, the least value is 1. So this 1 becomes the flow value for the next network. Okay, this flow value is added in this path only. Okay, 7 plus 1, 2 plus 1, 0 plus 1, 4 plus 1. So that is redrawn again here. So it is 7 plus 1 becomes 8, 2 plus 1 becomes 3, 0. Here initially it was 0 by 2, now it becomes 1 by 2. Now initially it was 4 by 10, now it becomes 5 by 10. So we have covered all the path, all possible path. So everything we are writing in the form of a table. So that is named it as augmenting path and bottleneck capacity. How many path you have selected, those paths you have to write. And bottleneck capacity, the flow value, whatever the flow value you have calculated after calculating the bottleneck capacity. So list out all the flow values. Initially we have taken flow as 4, next 4, next 5, 4, 2, 1. So the total maximum flow becomes 12. Okay, thank you.